The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a mathematical tool. Title of the video: Abacus multiplication, example 85 3 by 5 multiplied by 126 1 by 4. Multiplication of two mixed fractions did not give only a mixed fraction. Let us now change the first fraction into an improper fraction. Here, multiply the whole number 85 with the denominator of the first fraction 5. The multiplied value is 425. Now add the numerator value 3 with this and we get 428 as the numerator of the improper fraction with 5 as the denominator. Let us take the second fraction 126 1 by 4. In order to convert this into an improper fraction, multiply 126 with 4, which is 504. Add 1, the value of the numerator, which makes it 505, and therefore the improper fraction is 505 divided by 4. We can note down the values of the fractions separately on a braille sheet or using magnetic numbers. We have to multiply the numerators first. Let us set the multiplier 428 in the left extreme of the abacus. It has 3 digits and we have to add it with the 3 digits of the multiplicand, as the multiplicand is also a 3-digit number 505. Let us add one column for the abacus, and therefore 505 should be set up from the 7th column from the right side of the abacus. That is, number 5 is set in 1,000,000th column, followed by 0 in the 100,000th column and 5 in the 10,000th column. Let us start multiplying 5 of the 10,000th column with the number 428, for which the multiplication of 5 and 4 should be taken first. The value is 20, of which 2 should be set in the thousands column and 0 in the hundreds column. The next addition should start from the hundreds column. Now let us multiply 5 with 2, that is 10, of which 1 should be set in the hundreds column and 0 in the tens column. Next, we multiply 5 with 8, that gives 40, of which 4 should be set up in the tens column and 0 in the units column. That means the column is empty. Now let us clear 5 from the abacus. The next digit to be multiplied is 0. That means we simply ignore that and move to the highest digit 5. Let us start multiplying 5 with 4, that is 20, of which 2 should be set in the 100,000th column and 0 in the thousands column. Now 5 is multiplied with 2 and the result should be set to the right side of the number 2 in the 100,000th column, that is 1 in the 10,000th column and 0 in the thousands column. The next multiplication is 5 and 8, which gives 40, of which 4 should be added in the thousands column and 0 in the hundreds column. In the thousands column, we can't add 4 and therefore add 5 in the upper abacus, and to compensate this, clear one bead in the lower abacus. The multiplication is over now, and therefore let us clear the 5 of the multiplicand. The answer we get is 216,140. Let us take the denominators 5 and 4, and therefore the multiplication of them gives 20, which should be considered as the divisor. And let us set the dividend 216,140 and set the divisor to the left extreme of the abacus. As both the dividend and divisor have 0 in the last digit, we can cancel them out and consider the division as 21614 divided by 2. We can either reset the problem, or we can just simply go ahead with the division, knowing that the dividend and the divisor both have the last digits as 0. This is a simple division which gives a value 1, 0, 8, 0 and 7. And there is no remainder. At this stage, children will be able to do division involving single digit divisor by memory also. Though we used two mixed fractions, the result is a whole number, and this example gives an understanding that we should not assume that multiplication of fractions will give fractions only.